Have you ever stared at a reinforcement drawing and felt completely lost, trying to figure out what bars go where, how many you need, or how to calculate their total length? Or maybe you're in a situation where you are responsible for estimating reinforcement for beams, but you are not quite confident that your quantities are accurate. If this sounds like you are in the right place. In today's video, we are focusing on something that every quantity surveyor, estimator, site engineer, or even civil engineering student must understand: how to take off reinforcement in beams. Beams are one of the most essential load-bearing elements in reinforcement concrete structures. They serve as the horizontal support system, transferring load from the slab to column and eventually to the foundation. And because they play a crucial role, they are usually packed with different types of reinforcement: bottom bars, top bars, crack bars, stirrups, anchorage, and more, all carefully designed and laid in structural drawings. But how do you move from those complex looking drawings to actual quantities of steel in kilograms or tons? Or how do you know how many bars are required? What about the length, slabs, bend, hooks, and even cutting allowance? In this video, I'm going to be walking you through the entire process of taking off reinforcement in beams, step by step, no guesswork, no skipping, clear explanation with practical examples. Now let's get right into it. This is a drawing of our reinforced beam. This can be located anywhere. It might be ground beam, upper floor slab beam. The main purpose of this video is to provide relevant information on how to take off for reinforced beam, no matter where it is located. And now let's get into it. The section of our beam, this is 450 by 225. That's the depth is 450 and the width is 225. Most of our drawing for our beams or any structural work are drawn to center to center. So this is drawn to center to center. Now that we know the width of our beam, that's 225, and it is drawn to center, the first thing to do is to make our dimension external to external. So how do we get that? Since this is center, that's half of 225 to this side and half of 225 to this side. That's making 2 of half of 225. So when you multiply 2 by half, you get 1. Multiply by 225, that's you're adding 1 225. That's 1 width to the dimension in order to get external to external dimension. Before we move further, so let's come to assumption. So in order to successfully measure or take off for any concrete work, the first thing to do is just to check your general notes. From there you can get a lot of information about what you're about to measure, and that will make your work more easier and faster. So this is assumption. Since I don't have the general note here, this is just an assumption. So the cover to our reinforcement is 225. That means the distance between now part of the concrete to where we have our reinforcement is 25 mm. Then this point here, and hook is where we have links or stirrups. So I'm moving forward now. So the first thing to do is let's get the total length. That's from external to external. Remember I said half of 225. That's 2 multiplied by half multiplied by 225. So that's when we have 2 over 2 multiplied by 225. So that's invariably 1 multiplied by 225 plus 1575 plus 2725 plus 1500. This is the dimension here. Remember, we need to get the location of our reinforcement. That's why we are deducting 2 cover. So cover to this side and cover to this side. That's 25 to one side, 25 to the other side. That's 25 multiplied by 2. We have 50. So when we add everything together, we have 6025 mm minus 50. That's the cover of our reinforcement. So after deducting cover from the whole length, we have 5975. Now we have the length of our reinforcement. That's so from this point to this point is 5975 mm. So we need to get this length also, the length on the depth at this point we need to get. And so remember, we have 450 here. We need to deduct cover also. So 225 here and 25 here. So 25 multiplied by 2, we have so 450 minus 50, we have 400. Remember, we have the bend here. So we'll be adding bend to one side. So we can't add the two sides. So when we need to multiply, that is when we multiply by 2. So if we multiply by 2, it's going to be over measurement. So 100 here plus the 400 that we calculated here, 500. So from point up to this curve is 100 mm. So since we have two sides, it's going to be 500 multiplied by 2 equals to 1000. In order to get the total length of our reinforcement, that's one reinforcement. So from this point, this to this point, up to this point, going along this line to this point and back here. So when we add them together, 5975 plus 1000, we have 6975 mm. So the total length of one reinforcement, so from this point to this point, is 6975 mm. So moving forward, the quantity, we have 2 here. This is the quantity of our reinforcement. This is the diameter. This is the bar mark, and this is the location. This is at the top. So we have 2 of 16 mm at the top and 2 of 16 mm at the bottom, and it is one quantity. So that's 2 multiplied by 2, we have 4 multiplied by 6,975, we have 27,900 mm or 27.9 meters. So we need to calculate the weighting constant. That's the weighting constant of our reinforcement. Since we are using 16 mm from this drawing, we are using 16 mm, is going to be diameter square divided by 162. So diameter square divided by 162. This is a standard formula for calculating our weighting constant of any reinforcement. If you have 8 mm, you do 8 mm square. So any diameter that you have, to get the weighting constant, you square the diameter divided by 162. Since we have 16 mm, so 16 multiplied by 16 divided by 162, we have 1.5802. So in order to get the total quantity of our reinforcement in kg per meter cube, the total quantity we calculated here, that's 27.9 meters, multiplied by 1.580, we have 44.08758 kg per meter cube. One of the reasons why I used to write the whole formula without rounding it up until the last part is, reinforcement is very expensive and any mistake can cost a lot. So that's why I will leave it until the last part in order to round it up. So in order to convert to tons, we divide this quantity by 1000. So dividing 44.08758 kg per meter cube by 1000, we have 0.044875 tons. So when you approximate, you have 0.04 tons. So for this beam, it's going to take 0.04 tons of 16 mm reinforcement. And don't forget, we have in between, that's links or stirrups. So now let's go and calculate the links of the stirrup. Okay, this is our stirrup. Remember the section 450 by 225. Our length is 450, our width is 225. So in order to calculate this, the reinforcement here, we need to do the same thing. 450 mm minus 25 mm, that's the cover from this side and from this side, that's 50. So 450 minus 50, we have 400, and it is of two sides, so this side and this side. So multiply by 2, we have 800. Remember, we have this hook here and we said is 100, so plus 100, making 900 mm. The width we need to calculate for this, we're going to deduct 25 from this side, 25 from this side also, and in two places. So we have 225 mm less 25 multiplied by 2, we have 50. 225 minus 50, we have 175 mm multiplied by 2, we have 350 mm. We're going to be adding the hook also, that's plus 100, that's 450 mm. So the total length of our stirrup, total length is 900 plus 450, we have 1350 mm. And don't forget, we need to get the total number of stirrups we were not given. So now let's come to our drawing. So from the first one, that's 1B37. So from this point to this point, we are going to be getting the length. So what we need to do is, since this is half, we need to get from this point to this point. We are going to be deducting 225 from this. Half of 225 from this point, half of 225 from this, that's 1225. In order to get the length from this point to this point, and we are going to be dividing by center to center. Before moving forward, this is our diameter, this is the bar mark, this is center to center dimension, that's the distance between, let's say we have 1, 2, the distance between one stirrup to the other is 300. So the first thing to do now is 1575 minus 225. Let's come to the calculation. 1575 minus 225, we have 1350 divided by 300, that's the 300, the center to center dimension, we have 4.5. So when we approximate this, we have 5 plus 1 making 6. Where do we get this plus 1? So let's come in. At this up here, we are going to be having one reinforcement, so that's not taken into consideration when we are doing our calculation, but we usually have one to tie it at the end here in order to secure our reinforcement. So that's the reason why we normally add 1 to our calculation. I hope that is clear. So now that we have 6 for this point, we are going to be coming here to calculate this also. Okay, for the second one, 1 beam 38, so let's come here. 2725 minus 225, so that's 2500 divided by 300, that's 8.33. So when we round it up, we have 8 plus 1 making 9. So to the last part, we have 1005 minus 225, 1275. When we divide by 300, we have 4.25. When we round it up, it's not up to 5, so this becomes 4 plus 1, 5. In order to get the total number of stirrups or links that we have in between our beam, we are going to be adding the first one, which is 6 plus 9 plus 5. So the total quantity 6 plus 9 plus 5 equals to 22. The total length for our stirrup is equals to the total length here, 1.350 multiplied by 20, we have 27.00 mm. Don't forget, the diameter of our reinforcement is 10 mm. So in order to get the weighting constant of diameter 10 mm, mm of our reinforcement, that's 10 mm, is going to be 10 square divided by 162 multiplied by 27. So 10 square divided by 162 equals 0.617283 and so on. So we multiply this by 27, we have 16.67 kg per meter cube. In order to convert this to tons, it's going to be 16.67 divided by 1000. We have 0.02 tons. And that's all for today. So I'll be providing a link in the description below in order to download a workable or handwritten sheet for the explanation of this reinforcement in beams. That's it for now, and I'll see you in the next one. You're welcome.